All right. So let's get started on for chapter 9. So for chapter 9, we're not gonna be able to do this first page because this first page, well, it was the activity that we had to do in class. So we're kind of gonna scratch that. So we'll do some notes. So we're going to start working on confidence intervals. So I'm kind of going to give you the layout of how this chapter is going to work, because throughout the whole chapter, we're going to be doing confidence intervals. So for 9.1, 9.2, 9.3 is all going to be confidence interval. But the thing is, it's going to be different type of confidence interval. Kind of if you notice for chapter 8, it was kind of the same progression where chapter 8, we were finding the probability, but we're finding the probability for different parameters. So if you kind of remember for chapter 8, we were finding the probability, but we were doing the probability for when we had pretty much mu of x bar, but we were also finding the probability when we had, mu of p hat. But pretty much we're just finding the probability. So that's how chapter 9 is going to work. Because in chapter 9, we're going to be doing, so I'm going to put CI. CI is a shorthand representation of confidence interval. So we're going to be doing confidence interval for different parameters. So the first parameter that we're going to be working on is your population proportion. Then the second parameter we're going to be working on, the population mean. And then the last one we're going to be working on is standard deviation. So that's kind of going to be the overlay of chapter 9. Chapter 9 is all going to have to do with confidence interval. The only thing is we're going to be applying confidence interval to different parameters. So we're first going to start off with population proportion. Then we're going to move on to population mean. And then we're going to move on to population standard deviation. Everybody kind of go with that overlay of chapter 9. All right, cool. So let's go over what is a confidence interval. So what is a confidence interval? So a confidence interval, we use a confidence interval when I don't know what the parameter is equal to. So say you have a coin. Let me see if I can do a face on this coin. All right. So say we have a coin. So say we never seen a coin before, so we don't know how does the coin operate. And we want to find what is the probability the coin land on. So we're kind of interested in that. So we're interested, hey, what are the probability the coin would land on heads? So since I never seen a coin before, I don't know how the coin works. I have no idea if it should land on heads 40% of the time, 30% of the time, 50% of the time, 60% of the time. I just don't know. So what we're gonna do, we're gonna use a confidence interval to kind of narrow down what are the possible options for that coin. So the first thing you kind of want to go ahead and do is get a sample, because if I don't know what the proportion of the time the coin should land on head, we kind of want to get a sample, because the sample should kind of tell us approximately what it should be. So say we do a sample, we flip the coin and we get heads, tail, heads, heads, oops, heads, tail, heads, heads, tail, 1, 2, 3, 4, 5, 6, 7, 8. Actually, so say we flip the coin 10 times and we get this result. So based off of this result, what did we get? What percentage of the time did it land on heads?
60%.
Yeah, 60%. So this is p hat. So we say p hat is equal to 0.60. Because 60% of the time it landed on heads. Right, everybody good with that so far, where we get p hat equal to 0.60? All right, so up next, we're gonna go like, how confident are we that the proportion of head, or the proportion of time that would land on head, is 60%? Like, are you pretty confident that it should be exactly 60%? Yes, no, maybe? Well, if you kind of think about it, like, we shouldn't be that confident, because we're going like, we don't really have that much room for error. Because if we're saying it's gonna be exactly 60%, then we're relying a lot on this sample. So you kind of don't want to be confident on this answer. But what if I tell you I'll give you a margin of error? So I'll give you a margin of error of 20%. So I'm telling you right now, you don't have to be exactly right. It could be, you're gonna have a margin error of 20%. So that means it's a plus or minus. So that means if you're off by like just 10%, then you're good, because since I gave you a margin of error of 20%, it's saying it doesn't have to be exactly 60%, but it has to be within that realm or within that range. So when I say we have a margin of error of 20%, that means that we're gonna get the 60% and we're gonna plus and add 20% to it. So if I plus and subtract 20% from 60%, well, if I do 60% minus 20%, what would that give me? All right, thank you. So it should give you 0.40. So if I do 0.60 minus 0.20, you'll get 0.40. But if I do 0.60 plus 0.20, that should give you 0.80. So this is what we're talking about when we're talking about a confidence interval. So a confidence interval is an interval that we want to see how confident. So depending on our confidence, it kind of depends on the range. Because if you kind of think about it, the bigger the range is, the more confident you should be. The smaller the range is, the less confident you should be. Because if you have a bigger range, you have more chances of being right. Versus if you have a smaller range, there's more chances of you being wrong. So whenever we talk about confidence, confidence is related to how big of a range you have in your confidence interval. The bigger the range is, the more confident you should be. The smaller the range is, like, the less confident you should be. Let me see. Yeah, so if you see in the chat on the question, it says, what is the difference between confidence interval and margin of error? Or is it the same thing with different names? So pretty much it's kind of the process of how you get the confidence interval. So in a little bit, we're going to talk about something called a point of estimate and margin of error. But you need a point of estimate and margin of error to help you construct the confidence interval. So the margin of error is there to help us get the confidence interval. Because technically, if you kind of look at the margin of error was 20%, but I use that 20% in order to get the confidence interval. Because technically, this is our confidence interval. Oh, I think my computer stopped sharing, so let me just stop share and reconnect that. Yeah, so if you see what I highlighted in like hot pink, That's your confidence interval, but you have to use the margin of error in order to get the confidence interval. So if I look at this confidence interval, did this confidence interval give me the correct answer? Because we all hopefully should know the probability that a coin should land on head is 50%. So this confidence interval telling me it could be anywhere from 0.40 all the way to 0.80. So did this confidence interval actually capture the true population proportion of the percentage of time a coin should land on heads? Oh, yeah. So the answer should be yes, because if you look at 50% fall within this range. But what would have happened, say, if we would have done a margin of error of 5%? So if we would have done a margin error of 5%, we would have said 0.60 plus or minus 0.05. So if you do 0.60 plus or minus 0.05, you get 0.55 all the way to 0.65. And now if you look at it in this time scenario, it missed. Okay, it wouldn't give us 0.50. So we have to kind of be careful about how small we make our range, because the smaller you make the range, there's more chance that it could be wrong, because if we narrow down the options, like there's less options to choose from. But if we have a bigger range will most likely give us the correct answer. All right. So any questions so far about the idea of what the confidence interval is? All right. So let's get into 9.1. All right. But it's a margin of error is small. Actually, that will be the reverse. That will be the reverse, because the smaller your margin of error, the less confident you should be. The bigger your margin of error, the more confident you should be. Because if you kind of notice on these two, like I'm way more confident on this one over here, because pretty much it could be anywhere from 0.40 all the way to 0.80 versus this one. If you look at it, since it has a smaller range, because we gave it a smaller margin of error, you're taking to be less confident in that one. So because it's from 0.55 to 0.65. So yeah, it's the inverse. So up next, we're gonna go ahead and do, we're gonna go ahead and learn some new vocabulary word. So the math is pretty much the same thing. The thing is, what they call it, it could be a little bit different. So that's gonna be the little confusing part. Is pretty much we're doing exactly the same thing, but the only thing is, instead of calling it what we used to call it, they're pretty much giving it a new name. All right. So up next, we're gonna get into something called the point of estimate. So for the point of estimate, if you look at the definition I had there, it says a point of estimate is the value of a statistic that estimates the value of a parameter. So kind of think about it with this last problem. I didn't know what the population proportion was, but I was using p hat to help me figure out what the population proportion was. So that's what the point of estimate is. The point of estimate is telling me I don't know what the population parameter is, but I'm gonna use the sample, well, I'm gonna use the statistic in order to pretty much, what do you call it? Yes, to estimate what the population parameter could be. So pretty much all of this chapter, we're not gonna know what the population parameter is, but what we're gonna do, we're gonna use the point of estimate to estimate what the population parameter should be. So like for the flipping of the coin, I didn't know that the population proportion was 50%, but I used a sample, and from that sample, we got to estimate what it could possibly be. All right, so that's the point of estimate. And for chapter 9.1, since we're going to be doing confidence interval for population proportion, we're going to use p hat to estimate what p is equal to. So just remember, p, I don't know what p is, but I'm going to use p hat to estimate what it possibly could be. So if you kind of remember on 8.2, we went over the formula for p hat. It's the same formula. P hat is equal to x divided by n. The only thing different in 9.1, instead of calling it a sample proportion, they're going to call it the point of estimate. So if they're referring to the point of estimate, they're just asking to find p hat. Any question in regard to point of estimate or point estimate? All right then. So let's scroll on up and let's do our very first problem. So for this first example, it says in July of 2018, a university poll asked 1,783 registered voters nationwide whether they favor or oppose the death penalty for a person convicted of murder. 1,123 were in favor. So it says obtain a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty. So for this one, we want to find the point estimate. So pretty much what we want to do, we want to find what p hat is equal to. So we want to do x divided by n. So x is, what was that? So voters who are in favor of the death penalty. All right, so what do you put? Oh, I can put it. So that would go on top. So voters who are in favor of the death penalty. And it is pretty much people who they survey. No, we put registered voter. All right, so you go voter who are in favor of the death penalty, and you divide it by however many registered voters they got. All right, so let's do p hat. So p hat will be x, where x will be how many people are in favor. So you go 1,123, and you divide that by 1,783. So those are how many registered voters they sample. So I'm gonna do that in my calculator real quickly. So you get 0.6298. And if you look at that, you just stop at 4 decimal places. All right, and you're done. So if I talk about find the point estimate, you have to just figure out, is this the point estimate? Because the thing is, you're gonna have 3 different point of estimate. You're gonna have point of estimate for P, mu, and also sigma. All right, but that's it for point of estimate for a population proportion. Any question in regard to it? Alrighty. All right, so I think we're gonna go into margin of error. So if you kind of look at how we use the margin of error in the beginning problem about flipping a coin, pretty much the margin of error is kind of telling us how accurate of a point of estimate we want it to be. Because if we choose a small margin, well, if we get a small margin of error, that means we kind of want it to be pretty close to it. But if you choose a big margin of error, then you're okay with having multiple options. Because like the good thing about having a small margin of error, it kind of narrows down the possibility of what it could be. But when you have a big margin of error, like kind of think about it, if I were to tell you the people, well, kind of going back to the one about flipping the coin and finding out what proportion of the time it land on heads. If I were to tell you the proportion of the time it land on heads could be anywhere from 0% all the way to 100%, like, am I gonna be right? Like, yes, I am gonna be right. But if you kind of think about it, is it gonna be useful for me? If I tell you it could be anywhere from 0% to 100%, you kind of go like, no, duh. Like, I already knew it should be anywhere between 0 to 100%. So I didn't really narrow it down. So that's kind of like the bad part about getting such a big margin of error. If you get a big margin of error, you're not really narrowing down the possibility. So you kind of know there's several things that could affect your margin of error. Sorry, the computer froze, or the sharing techniques froze. Right. So there's a bunch of factors that go into the margin of error. So I'm kind of going to show you that right now in a simulation. Hopefully this simulation goes better than the Gettysburg simulation. All right. So the level of confidence, that will actually affect your margin of error. Also, your sample size will affect your margin of error. And the standard deviation of the population will also affect your margin of error. Because the bigger your standard deviation, the bigger your margin of error will be. So right now we're going to focus on level of confidence and your sample size, because the level of confidence will affect your margin of error. Because the more confident you want to be, the bigger your margin of error should be. The less confident you want to be, the smaller your margin of error should be. Same thing go for the sample size. For the sample size, technically a bigger sample size means you get a smaller margin of error. Because if you have a bigger sample size, it should be more accurate. If you kind of think about it, if I have a sample size of 1 versus a sample size of 100, the sample size of 100 should be more accurate. Since it's going to be more accurate, that's going to produce a smaller margin of error. If you have a sample size of 1, that's going to be less accurate. So if it's less accurate, that means you're going to have a bigger margin of error. But let's go ahead and do a simulation. But any questions so far in regard to the idea of the level of confidence and the sample size? All right, so let me see. So we'll go to Rodman. Yeah.
Can you explain the relationship again for the standard deviation?
Well, for the standard deviation, kind of think about it. If you produce a bigger standard deviation, because with the standard deviation, it'll get a little bit clearer once you see the formula. Because
Okay, what's the relationship? Is it the standard deviation number is higher than the margin of error higher, or which one is it?
Correct. For the standard deviation, the bigger your standard deviation is, the bigger the margin of error will be. Because if you actually just go down, if you look at the actual formula for margin of error, you will see that the margin of error is z times standard deviation divided, is z times square root of p times 1 minus p divided by n. So you have z multiplied by the standard deviation of the sample proportion. So okay. the bigger the standard deviation you get, the bigger your margin of error is going to be.
Got it. Okay.
Yeah. Where is confidence in the confidence? Cool. So there you go, confidence. Perfect. All right. So it's kind of let you know how the simulation works. So the way the simulation works, if you look right here where it has this pi, that technically is not pi, it's your population proportion. Unfortunately for them, the way they write population proportion, they write like the pi symbol. So right now, if you look at it, let me zoom in on it. it's showing that pi is 0.50. So it's saying we're gonna let the population proportion equal to 0.50. So for this one, it's saying n. So it's saying the sample size that we're gonna be retrieving from this population of 0.50 is gonna be 100. And with the interval, it's saying we're only gonna construct one interval. And if you look right here where it says conf level, it's confidence level. So it can say confidence level of 95%. So what we're gonna do, we're gonna mess around with this simulation. And you see like how would the confidence interval get affected if I switch the confidence level, if I make it from 95%, if I make it to 65%, or what happened to the confidence interval if I increase the sample size or decrease the sample size. So you kind of remember, the bigger the confidence interval get, that means the bigger the margin of error get. If the confidence interval gets smaller, that means the margin of error is getting smaller too. Because in order to get the confidence interval, you have to add and subtract the margin of error. So once again, if the confidence interval getting bigger, that means margin of error is getting bigger. If if your confidence interval getting smaller, that means margin of error is getting smaller also. So you kind of know, like, if margin of error goes up, confidence interval will get wider. Margin of error goes down, confidence interval will get smaller. All right, so let's go ahead and play around with this. So let's do a sample. All right, cool, great start. All right, so if you look at the black vertical line, you should see that the black vertical line on the very top, it says 0.50. So pretty much it's telling you this is the population proportion. If the confidence interval contains 0.50, we're gonna give it a green light or a green color. So if you look at this red interval that we have, this is our confidence interval. So if you look at the confidence interval, it says it's from 0.525 all the way to 0.715. So the reason why it gave me a red versus it being green is because if you look at the interval, it's going from 0.525 all the way to 0.715. So if you look at 0.5, it doesn't fall in between those two numbers. So that way it's red. So let's do another one. What was that?
So is the confidence level always, if it's supposed to be an accurate confidence level, does it always include the mean?
Well, it will include the mean of the sample.
Okay.
But it's not always going to include the mean of that parameter. Okay, if you look at this one, it didn't include it. So that means that this confidence interval wasn't able to produce the population parameter that we wanted. All right, so let's do another sample. So if you look at this case scenario, we actually got a green confidence interval. And if you look at it, the reason why it's green, because the interval that we got for this confidence interval does contain the 0.50. So if I actually click on it, if you look at it, it's saying it's from 0.442 all the way to 0.638. So if you look at it, 0.50 fall in between there. So it giving me a green marker because it's telling me we were actually able to capture the population parameter. So anytime you see green, green means good. Anytime you see red, red means bad. Everybody kind of good with how does this work? Okay, so let's go ahead and let's start messing around with the confidence.
Kind of.
That's all I want right now. If you kind of got it, you're good. Okay, so right now we're gonna go ahead and mess around with the confidence level. So we want to see how does the confidence level, how does that affect my confidence interval? So what we're gonna do right now, I'm gonna get a confidence level and I'm gonna go from 95% and we're gonna move it over all the way to, say, let's do 60%. So we'll say 60%. So what should happen with the confidence interval if I'm going from a confidence level, here, let me put it in the chat. So we're going from 95% to 60%. So should it get wider or should it get narrower? So if we're becoming less confident in this confidence interval, will we be less confident if it become wider, or will we be less confident if it become narrower? Oh,
Wider.
all right, so let's check that out. Let's see what happened. So let's do the sample. Oh, I can't press it. All right, so if you look at it, what happened? What happened to my confidence interval? Did it get wider or did it get narrower? Well, if you're looking at it, you should kind of notice it actually got narrower, because the thing is, if we're losing confidence in this confidence interval, the only time we lose confidence in our confidence interval if it becomes narrower. So the confidence level, if your confidence level goes up, your confidence interval should also go up. But if we actually reduce our confidence level and make it go down, our confidence interval will actually get narrower. So you do kind of want to understand how that works. So if confidence interval goes up, confidence level goes up, your confidence interval should get wider because we're more confident in a wider confidence interval. But if your confidence level goes down, you're going to get a confidence interval that's narrower. Everybody good kind of that idea? All right, so let me change this back to 90. Let's do 95%. All right, so what we want to do now, we want to see what's going to happen if we change the sample size. So say if we go from a sample size, so I'll put this in the chat. We'll go from a sample size of 100 to 10. What should happen when my confidence interval? Will it get wider or narrower? And before you answer, let's kind of think about it. So which one would give me a more precise answer, 100 or 10? Like, which one will you have more confidence in, a sample size that have 100 object or a sample size that have 10 object? So you should be more confident in a sample size that have 100 versus a sample size of 10. So yeah, so if you have a sample size of n, well, if you have a smaller sample size, you're gonna have a bigger margin of error. So if I reduce this sample size from 100 to 10, you're actually gonna get a wider, you're gonna get a wider confidence interval because you're less precise. Because the bigger the sample size you have, the more precise your answer should be. So if it's more precise, that means it should be giving you a narrower answer. But if it's less precise, that means you should have a smaller sample size. So let's change this from 100 to 10. So if you look at it, we got a wider confidence interval, and the reason why we got a wider confidence interval because we reduce our sample size. So since we reduce our sample size from 100 to 10, it's saying we're gonna get a less precise answer, and a less precise answer means a bigger confidence interval. If we get a more precise answer, that means we get a narrower confidence interval. Because if you kind of think about it, if you have a bigger sample size, you're gonna trust the bigger sample size more compared to a sample size that's smaller. Because a sample size that's bigger should give us a more accurate answer versus a sample size that's smaller should give us a less accurate answer. All right, so just know if your sample size goes up, that means you're gonna get a smaller confidence interval. If your sample size goes down, you're gonna get a bigger confidence interval. All right. Everybody good with that? Or somewhat good? Okay, so we're gonna do the very last one. So whenever we're doing a confidence interval, pretty much a confidence interval, you're not only doing it like one time, you're doing this multiple times. Because kind of think about it, you're gonna be collecting data set multiple times. So you're gonna be getting a data set of 20 people, and then you're gonna calculate what did that give you, and then you're gonna go out and get another sample size of 20 people and create a new confidence interval for that one. So usually when we're doing a confidence interval, we're usually focusing on the method. So the method is that we're not getting one sample and just relying on that one sample. We want to get multiple samples, and that way we can get a more accurate reading. So when we're doing a confidence interval, technically we're not just doing one confidence interval, you're doing many confidence intervals. Because what the confidence level also represent, it represents how confident we are in this method. If we repeat the process over and over again, the confidence level telling us how many times we should get it correct, how many of those times or how many of those samples will get it incorrect. So the 95% telling us 95% of the time, if we repeat this experiment, 95% of the time, the confidence interval will actually give us the population parameter. The other 5% of the time is not going to give us a population parameter. So right now, what I'm going to do this. I'm going to do 100 interval. So instead of just having one interval, we're going to have 100 interval. So if we do have a 95% confidence level, that means of these 100 interval, I should expect 95 of them to be green. The other 5 should be red. But just remember with anything, that's just the expectation, but that doesn't mean we're actually gonna get 95 green, 5 red. We might get like 94 green, 6 red. So let's go ahead and see how many do we get. No. So if you look at this, I have 100 confidence interval. And if you look on the left side, if you look at the left lower corner, it says interval containing the population proportion. So it's saying 90 contain it out of the 100. So it's saying it was right 90% of the time. So that's what the confidence level is also telling us. It's telling us if we repeat this method, 95% of the time, the method should give us the right answer. The other 5% of the time, it should give us the incorrect answer. All right, but that's it for this simulation. Any question in regard to the simulation? All right, so I'm gonna transfer over to notes, and you're gonna jot down some of the things that we did. So let's kind of just say what happened to the confidence interval or level of confidence. So I'll put LC for level of confidence. So if we increase the level of confidence, our confidence interval also increased or got wider. If we got the level of confidence, if we decrease it, our confidence interval actually got narrower. So that's how the level of confidence is affected if we increase it or if we decrease it. So kind of think about it. So if level of confidence is increased, the confidence interval is also getting wider. If level of confidence is decreasing, confidence interval is getting narrower. So that's how level of confidence affects your confidence interval. So let's do sample size. So if we increase the sample size, what's going to happen? Our confidence interval is actually going to get narrower because the bigger sample size we have, the more precise our confidence interval should be. So it should be getting narrower. the smaller your sample size get, the wider your confidence interval should be getting. So that's pretty much the two things you should have gotten out from that simulation. How does the level of confidence affect your confidence interval? And how does your sample size affect your confidence interval? And hopefully you should know that margin of error, if margin of error goes up, confidence interval goes up too. If margin of error goes down, confidence interval goes down. All right, so we're all done with the simulation. So now we're actually gonna do some problem, or you're gonna see the formula. All right, so these are the formula we're gonna be using. So for the critical value, we're gonna use the t-table to find this. So for right now, don't worry about how to find that. Yes, no, we're gonna use the t-table in order to find that. So up next, we're gonna do E. E stands for margin of error. So if you look at the formula, you get the Z value and you multiply it by square root of P hat times 1 minus P hat divided by N. If you remember in chapter 8.2, we were using this formula, P times 1 minus P divided by N. So the thing is, the reason why we had to substitute P hat instead of P, well, if you remember confidence interval, I don't know what the population parameter is. So I don't know what P is equal to. So we're gonna use the best point of estimate to estimate what P could equal to. So that's where P hat come from. So since I don't know what P is equal to, we're just gonna use P hat in order to substitute for that because we don't know what P is equal to. So we're gonna put P hat as a replacement. And then you divide it by N. So this is how we're gonna find the margin of error. Any question for the margin of error? So here goes the point of estimate. So the point of estimate is equal to P hat, which is just equal to X divided by N. So once you find point of estimate and once you find margin of error, it's pretty straightforward. We get the point estimate, we plus and subtract it from the margin of error. Here goes a shorter formula for it. We get P hat plus or minus E. E represents margin of error. P hat represents the point of estimate. Everybody good so far with the formula or any question about any of the formula?
Where it says the note, that's a little bit confusing. On the top.
Yeah. Okay, so pretty much what alpha is the remainder. So kind of remember if we do 95%, so this is your confidence level. In order to find alpha, alpha is equal to 1 minus confidence level. So pretty much to get alpha, you do 1 minus confidence level. If confidence level is equal to 95%, you do 1 minus 0.95, which is 0.05. So if you look right here, it says 1 minus alpha. Oh, well, sorry. For some reason, it's not sharing that portion. Let me reconnect that. Here, let me do this again. All right, so confidence level, so we're gonna say confidence level is equal to 95%. So in order to find alpha, you do 1 minus confidence level. They do 1 minus 0.95. So if you do 1 minus 0.95, you get 0.05. So right here, we're saying 1 minus alpha multiplied by 100%. So you do 1 minus 0.05 times 100%. So 1 minus 0.05, that's going to give you 0.95 times 100%, which if you do 0.95 times 100% will give you 95%. But yeah,
Okay.
it kind of telling you pretty much how you get it if you have alpha. But for the most case, you should always have the confidence level.
Gotcha. Okay.
All right. Any other questions? All right. All right. Also, just remember for this one, we still could use the central limit theorem. The only thing that's going to happen for the central limit theorem, we also have to adjust the formula for the central limit theorem. Because if you remember, we have n times p times 1 minus p. But the thing is, we don't know what p is. So what we're going to do, we're going to replace p by p hat. So we're going to do n times p hat times 1 minus p hat. And we're going to check to see if that's greater than or equal to 10. So for this one, we're also going to be using the central limit theorem. The only thing different, instead of saying n times p times 1 minus p, you have to adjust that we don't know what p is anymore. And we're going to have to use p hat as a replacement for it. Everybody good for that? All right, so let's do our very first problem. So our very first problem is going to be a basic problem. So we're going to have x is equal to 120. We're going to have n is equal to 500. And we're going to have a confidence level of 95%. So first thing I'm going to go ahead and do, is find z alpha divided by 2. So I'm going to find what that is equal to. So I'm going to show you the technical way that you're supposed to find this, but I'm also going to show you the easy way of how to find this. So when we look at the confidence level is 0.99. But if you look at alpha, well, if you look at this, we want to find what alpha is equal to. So alpha is equal to 1 minus confidence level. So you go 1 minus 0.99, which is 0.01. Any questions so far on how I got the 0.01? Okay, so far we have z of 0.01 divided by 2. So then you go 0.01 divided by 2. What's 0.01 divided by 2? Well, let's do that in our calculator. So let me transfer over to my TI-83. Oh, 84. So we'll do 0.01 divided by 2. All right, so we got z of 0.005. Right. Everybody good on 0.005? Okay, so I'm gonna transfer back to the notes. All right. So once you get z of 0.005, what you're gonna do, you're gonna look for this in the z table. So on the z table, well, sorry, on the t table. So let me go ahead and download the t table. So I'm gonna put right here the z value that we got. So we got z of 0.005. So all you have to do is look right here for 0.005. So if you look right here, here you go 0.005. Everybody see that 0.005? All right. So also, if you look all the way in the bottom of the z table, or sorry, the t table, you're gonna see where it says Z right here. So what I wanna do, I wanna go all the way down and see where does that intercept. 'Cause I wanna see where does this row intercept with that column that I chose for 0.005. So if you look at where do they intercept at 2.576. So we get Z of alpha divided by 2 is equal to 2.576. And that's it. All right. Any question on how I got 2.576? Yeah. So that's the technical way that you would get it if you want to use alpha and if you want to find it. The either way, just use the confidence level. So if you remember for this one, what did I tell you the confidence level was equal to? If you could you put it in the chat too. So if you look at the original prompt, what did I say the confidence level was equal to? Cool. Thanks, Caesar. So we said it was 99%. If you have the T-table with you, if you look right here, it says confidence level. And then it has a different type of confidence level here. So if you look at it where it says 99%, and then if you look at the number right above it is 2.576. So technically you only need to know the confidence level and just know the number right above it, which is in the Z line. That's gonna be the Z value. And that's it for how to find that critical Z value. Any question how we found 2.576? Okay, so let me go back to the notes. So we say 2.576. All right, so that's our Z value. So up next, we're gonna go ahead and do, we're gonna get the point of estimate. So we're gonna get what P hat is equal to. So P hat is equal to X divided by N. So X is 120, N is 500. So let's do 120 divided by 500. So you get 0.24. All right. So that's P hat. Any question on how I found P hat? Okay, so up next I'm gonna find is this over here. I'm gonna find P hat times 1 minus P hat all divided by N. So that will be equal to 0.24 times 1 minus 0.24 all divided by N, which N is equal to 500. And in case you're wondering where did the 0.24 came from, the 0.24 came from the number that I just found. Any questions so far on square root of 0.24 times 1 minus 0.24 divided by 500? All right, so I'm gonna go ahead and work that out. So it's a 0.24 times 1 minus 0.24 divided by 500. You get 0.0191. So just remember, this is my standard deviation. So I just found what standard deviation of P hat is equal to. What I'm gonna go ahead and do next, I'm gonna go ahead and find the margin of error. So for margin of error, if you look at it, it says you get V alpha divided by 2, and you multiply by P hat times 1 minus P hat, all divided by N. But the thing is, I already found each one of these individually. I already found that Z value is equal to 2.576. And I already found the standard deviation of p hat is equal to 0.0191. So all I'm gonna go ahead and do to find margin of error is multiply those two values. So you go 2.576 multiplied by 0.0191. If you multiply that out, you get 0.0492. Once again, kind of notice I'm using 4 decimal places. Usually when you're dealing with proportional data set, you use 4 decimal places for that way you could be fairly accurate. All right, but any question in regard to so far how I got margin of error? All right, so the last step that we want to do, we want to find the confidence interval. So if you remember from the formula, to find confidence interval, you get p hat plus and minus margin of error. So p hat, we found it to be 0.24 plus or minus margin of error, which we found to be 0.0492. So just remember, let me move this up here if I could get more space. Just remember the plus or minus mean you're doing the operation twice. So technically you're gonna be doing 0.24 minus 0.0492. But you're also gonna be doing 0.24 plus 0.0492. All right, so let me go over to the TI-83 and I'm gonna do that in the calculator. So we'll turn it on. So we'll say 0.24 minus 0.0492. And you get 0.1908. I'm going to do this again. The only thing I have to change, instead of having a negative, we're going to have a positive. So we're going to add. And if we add this, you get 0.2892. And that's your final answer for the confidence interval. So technically there are 2 ways that you could write this. And right now, once I switch over to the notes, I'll show you the 2 ways. All right. So you can either write it this way, or you could write it this way. Both ways are the same. Yeah. But that's how you find the confidence interval by hand. Any question on how we found the confidence interval by hand? All right. So last thing we're gonna go ahead and do, I'm gonna show you how to double check your answer using the calculator. So for the calculator, you only need 3 things. You need X, you need N, and you need your confidence level. So let me switch it over to the TI-84. All right, so first thing you wanna do, you wanna hit the stats button. And what you wanna do, you wanna migrate over to where it says tests. So just move it to the right all the way to test. If you look at it in the 7th position, you should see where it says Z interval. So we don't actually want that. We actually want one that says proportion. So we keep on going down. If you look at number, well, not number, but letter A, it says 1 prop Z int. Int means interval. So we're gonna do 1 prop Z interval. So you're gonna want an X value. So just to kind of let you know, the X value should always be a whole number. If you do give it a decimal, it's not gonna like that answer and it's gonna give you a syntax error. So X should always be a whole number for this one. So for this one, you put 120 for X. For N, you put 500. And then for the confidence level, you put 0.99. And then you go to calculate. And if you look at it, it gives you exactly what we got in our calculator. And the good, well, sorry, by hand. And the nice thing about it, it also gives you the p hat. So if you look right here, it says p hat is equal to 0.25. It has n is equal to 500. Any question in regard to that? All right then. All right, so that's it's pretty much that's gonna be it for today. So just gonna kind of let you know, on Monday you're gonna have a quiz. Quiz is gonna cover chapter 8.2. So just focus on 8.2. So that's pretty much what we did today in the first hour of the class. So if you know 8.2, you should be fine for Monday quiz. And also just remember, if you still haven't turned in the test correction are due today at the end of today. So do try to get the test correction in as soon as possible. For that way you don't have to worry about in case your internet go down or anything like that. Try to get it in the sooner the better. Any question before I close out the meeting? All right, so there's no question. I'm gonna close out the meeting. So I'll be in my office hour like in 5 minutes. So if you do have any question, I'll be in my office hours in 5 minutes. But that's it for today. Have a good day and have a nice weekend.